Hey everyone, happy Saturday. So today is day 3 of our stream, and thank you guys for joining us on Saturday. Let's take a look at where we were from yesterday. So yesterday we made really good progress on our application. We started our React tutorial, and we also went through and looked at the whole architecture of our application and how the different components of the application fits together. So today I think we're just gonna continue on pushing forward and seeing what else we can accomplish. We left off on the React tutorial midway through. We were pretty excited to start the tic-tac-toe tutorial, but we still have about half of the first page to get through. So let's take a look and recap. Switch to desktop view. All right, so we were at, just for those of you that missed yesterday, we were at react.dev. ChatGPT basically told us to go to this URL to learn React, which we did, and we noticed that it was an old version of React. If you take a look, it's a deprecated version. The site is no longer updated. So what we did is actually go to the latest version, which is this website over here, and we're going through the quick start guide. Apparently, if we get through the quick start guide, we'll already have 80% of the knowledge that we need to use React, which is going to be amazing, right? I think that's going to be amazing. Sorry, I'm adjusting my microphone. So yeah, we'll have 80% of all we know by finishing this. I think we got down to conditional rendering, and we were about to start rendering lists. Before we start finishing up the tutorial, or finishing up the React tutorial, let's try to make our diagram from our iPad a little bit more clear. So if you guys remember from yesterday, we went over writing the server side diagram of our application and the front end side of the application. This is super messy, and I want to make it a little better. So let's try to make it on a tool on our desktop. So what I like to use is Figma. I think Figma is very, very useful for making things like this. I really enjoy, okay, let's sign in real quick. All right, let's go back to files. So I really enjoy using Figma, and particularly their FigJam board. I think this FigJam board is awesome. And then we're gonna use a template. Let's see what template we can use. FigJam board. All right, some templates. We want to make a flow chart of sorts, I believe. Yep, let's make a little flow chart. And then we even have little icons here. That's awesome. All right, so let's delete this. All right, so to convert this mess of a, sorry, 1 second. All right, to convert this mess of a diagram to FigJam, let's start by defining little blocks. Let's put a little square box here. So we're gonna call this Node.js, right? We have Node.js over here, and then we have Express that rides on top of Node.js. And then we have Express and Node feeding us a bunch of API endpoints, right? Yesterday we talked about what APIs do. They allow different parts, different programs to communicate with each other, right? So the client side can communicate to the server side. So we have a bunch of APIs. And specifically, we're talking about REST APIs. All right. So this is equivalent to this section over here of our iPad. And then on top of that, we have our JWT passport. To manage user authentication, right? So let's make it a little smaller. And I think there's a return here. All right, so I believe that this rides on top of Express, which rides on top of Node.js. All right, so let's put JWT on the side over here. So I believe that JWT is a piece of middleware which interfaces with Express and allows us to easily add user authentication. That's why we put it on the side. All right, so, and then Node.js will probably give us the API endpoints or Express. We're not sure yet. Let's just put them like that. Cool. All right, so we have the top part of our server side application represented in FigJam, which is great. Let's make the bottom side. So how does Mongo interact with all this? Let's copy Node.js. So we have MongoDB, and then we also have Mongoose. Mongoose is a framework that is a tool or like a framework that allows us to turn MongoDB documents into JavaScript objects that into objects that our programming language can understand. So we don't have to manually process every single JSON file in MongoDB. So let's draw a couple JSON files here. Right, so MongoDB has JSON documents that it stores. And then Mongoose allows us to interface with these JSON documents to turn into JavaScript objects, right? So Mongoose looks at MongoDB. MongoDB has a bunch of JSON documents. And then Mongoose can talk to Node.js, right? So we can connect Mongoose to Node.js, and this will allow us access to user data. Let's put a little sticky note here. So this stores our user data, right? This includes data on career details and what else? Career details and maybe like the schedules, a average daily schedule that people submit, right? And all other user data. Okay, so that's this section down here. Mongoose lets us talk to Node.js. Node.js has our business logic, right? So the website the backend logic and authentication business authentication. All right, so business logic and authentication goes over here. That's this area. And I think Figma has this, yeah, it has this section feature, which is awesome. So this section is business logic plus authentication. Okay, and we'll just leave a sticky note there. And then this portion on the bottom this section stores user data. Awesome. And then we can put some sticky notes in case we have notes in the future, right? And let's make all this font bigger just because the font's so small you can't see anything. Medium. Large? Is large too big? All right, let's do medium. Okay, perfect. So this is the server side, right? And let's put one more section. Let's just call this the server side. Okay. I think trying to wrap this thing kind of makes it really ugly. So let's just wrap this whole thing in a square with no fill. Or a rectangle with no fill. And then we'll call this the server. Let's make this a different color. Okay. And then how do we put some text over here? Right here. Actually, we could just put a green box right here. This is our server. Awesome. Okay, and then these labels are, I don't like how the labels move around. Let's just make our own. Oops, too small. All right, so great, we have our own labels now. And the reason I'm doing this is because if you zoom in and out, I think these labels auto resize, but it kind of makes things a little confusing, which is why I'm just copying this and creating our own label, which is fine. User data. Cool. Let's make it closer so people understand it's next to each other. Okay, great. We can zoom in a little bit. All right, so this is our server. You can see our server has the user data part and the business logic part. Now let's make our client side. So if you look at our client side, it's much simpler. All we have is React over here, and we have D3.js, and then just a browser for the front end. Let's copy this. Let's just make take this one over here, and we'll call this React.js. React.js lives on the browser, on the client, and then we also have D3.js. The nice thing about JavaScript is that everything is written in JavaScript, including the client side as well, right? Or including the server side. So back then when I did web development, when you wrote server code, it was mostly written in Java. So what you had to do was write JavaScript on the client side, and then in the back end, you either use Ruby or Java or Python. You can still use those different languages nowadays, but I think majority of popular web development uses JavaScript now for the back end. Okay, so D3.js plugs into React. And then all of this is served on a browser. So Google Chrome, for example. Right. And this is all hosted in the browser, and then we'll call all of this stuff, excuse me, call all of this stuff the client side or the front end. And this is the back end. Perfect. Just gonna center this for a second. And there we go. There we go. So now we have this ugly diagram that I drew by hand into a much nicer diagram on the computer, right? We can move things around. We can add notes, right? We can add notes about React. So for React, we're working on a React tutorial. So why don't we do that? Why don't we point here and say, we're making progress with react.dev.com. I mean, react.dev, right? Let's just put that resource over there. Oh, wow. Oh, this is really nice. Okay, so FigJam knows that we made a link, so we don't even need a note. We can literally just stick this guy there. I like that. And how do we do arrow? We can arrow to it. Perfect. Great. This is great. This is why I love Figma. Move the arrow so it's prettier. Okay, cool. Okay, and then let's give a change the color a little bit. This is a lighter color. And then let's give a title to this thing. We shall call this Architecture of our web app. For now, I don't think we don't have a name for this app yet. I think that's something that we should brainstorm, and we will do that soon. But let's go through our React tutorial. So yeah, this is a general overview, and I can see if I can send this to a PDF file, export as PDF. Great. So we have all that great information on a PDF document, and unfortunately you cannot click on this, but that's fine. We can use the Figma. So I'm gonna share this PDF. Actually, let's put one more box, and this will be the title of what this whole thing is. Okay, perfect. Let's export as a PDF again. Great. So I'm going to share this on the Discord page. If I haven't said so yesterday, we have a Discord page for everybody to participate in. It'd be awesome if people could hop into the Discord page, because it'd be nice if everybody could put their input in. I can more easily cater the content to what you'd like to watch, and you can totally join into the conversation and design this together with us. We'd love feedback from students, from parents, from friends, and once we are able to get some good feedback, we can make something that's useful for you, right? And yeah, let's grab the PDF and share it to the Discord. So again, I can show the Discord over here. We have Y Academy stream. I'm just gonna drop this file into the Discord. All right, so if you guys join the Discord, you'll be able to access this PDF document and follow along, right? Okay, And let me also close my Photoshop because I was making a thumbnail for yesterday's video. All right. Continuing on. So where were we on our React tutorial yesterday? I think we were at rendering lists, right? So what did we learn yesterday? Yesterday we learned things about conditional rendering, which is a way of using JavaScript to render different components. We learned what a component is, and we played around with components. We even made a large rubber ducky on the demo screen over here, which is awesome. Okay, excuse me, my nose is kind of itchy. All right, so we were able to use make React components. We learned that components can only return one component. If you want to return more than one component, you have to wrap it in a div or an empty wrapper, like so. Right, a div or an empty wrapper. And JSX is a language that React understands, and it is able to parse in line with JavaScript. You can escape JSX using curly brackets, and you can display data using curly brackets to use JavaScript to parse things. And then we also learned that we can pass on class attributes as a JSON object to React in order to set different attributes, right? So you can do a style with a width and height, things like that. All right, so continuing on, we're halfway through already. Rendering lists. You will rely on JavaScript features like for, loop, and the array map function to render lists of components. For example, let's say you have an array of products. Okay, so we have a product and it's in the list. Inside the list is a dictionary or a JSON, an object that has a title and an ID, right? And in the list, there are 3 items in the list for cabbage, garlic, and apple, each one with a different ID. So in the component, you can use the map function to transform any array of products into list items. All right. So what the map function does is it goes through every single item in the list and it does something to the item, right? What does it do with the item? I think that's what this JavaScript function is. So I think this is an arrow function. So let's look up what an arrow. Let's see if it talks about an arrow function. Okay, it does not talk about arrow functions, but I think it assumes that you know what an arrow function is. Let's look up JavaScript. All right, let's ask ChatGPT. Let's update ChatGPT. So hi, ChatGPT. We have finished about half of the intro to React.js tutorial. We are on the rendering lists area section, and it is showing us an example that includes JavaScript arrow functions. Can you show us some resources? Can you explain arrow functions and show us good resources to look at? Oh wow, okay, this is pretty cool. So what is it saying? Absolutely. Arrow functions are concise syntax introduced into EMC script 6. So EMCA script 6 is the official JavaScript specification. They provide a more concise and expressive way to write functions compared to traditional function expressions. Here's a brief explanation of arrow functions. Arrow functions have a simplified syntax that omit the word function keyword and uses the arrow instead. All right, so you can define a constant. The constant has parameters, and then this is the arrow function, and then this is the function body. In the above example, my function is an arrow function that takes two parameters, parameter 1 and parameter 2. The body is enclosing curly brackets, right? The benefits: it's concise, you don't have to write so much. Lexical this. So do you guys, in a lot of programming languages, when they have a lot of keywords such as this or self, in Python itself, I think in JavaScript it's this. The concept of this or self is actually based off of classes. So when you're making a class, you're actually creating a recipe, right? Objects are, you can think of objects as a representation of a recipe. So in order to make, I have my AirPods over here. In order to make AirPods, somebody had to make up instructions for the AirPods, right? Somebody had to make a schematic, they had to draw all the designs, they had to figure out the materials that goes into this. You can think of a class as the instructions to making this AirPod. When you instantiate that, when you instantiate an object, it means that you use the class. So somebody wrote some instructions on a notebook to make an AirPod. You go through this class and then you make an object over here, right? In order to tell the object to operate on itself, you use the keyword this inside the class description, right? So if, for example, the developer wanted this AirPod to play some sounds, in the class instructions, they would say this dot play sound, right? This is referring to the recipe, the thing that the recipe is going to make, right? So every single AirPod will have their own this, and that's because they're objects. But the main use is inside the class, you just say this dot do something, right? And it refers to the object that you're making will do something. So in this sentence is saying lexical this binding. Unlike regular functions, arrow functions don't have their this context. They inherit this from the surrounding scope. This behavior helps avoid confusion and simplify the handling this within functions. So it sounds like in an arrow function, it assumes the this of whatever, wherever this was defined. It doesn't have its own this. It just takes the this of whatever, wherever it's made. So in the AirPods case, if you use an arrow function, it will use the this of the AirPod. If the function body consists of a single expression, it automatically returns the result of that expression without needing to write an explicit return. Okay, so that's cool. That means that in an arrow function, if you just have a single expression, then the result of that expression is returned. You don't need to type return. Okay, so these are some good resources for arrow functions. Let's take a look at the MDN web. Okay, so arrow function expressions. Try it. Oh, this is a nice. Okay, so this is a good example where you don't need a return, right? So this is saying you map all the materials. For each material, you return the material length, right? Normally, you would have to put return here. I think you can still put return there, and it still should work if you spell return correctly, of course. Okay, I guess you don't. Oh, okay, so you have to put curly brackets. So if you scope it and then you put return. Great, so it still works, but because of convenience, you can remove. Let me make this bigger so you guys can see. So this is without the return, right? Implicitly or lexically, it assumes if it's one line, you can return. It returns the expression. But if you want to add your own return statement, then you can go like this, and it's still the same result. Okay, so that's a quick brief on arrow functions. Let's go back here. So how does this relate? So this relates by saying, hey, for every single product, we are going to return, because we're returning something, a list component, right? So this is our syntax to make a component, and or it's not the syntax to make a component, but this is JSX. So this is a JSX object, right? A list object in JSX. It's only one object, and it's returning a list with a key of product ID and a title of title. And then what are we returning? We're returning all the list items. So how does this work? Inside your component. Okay, so this is inside a single component. Let's take a look. All right, so we have a list of products over here, and we have our component called shopping list. In the shopping list, you can define some pure JavaScript, right? So we're defining some pure JavaScript. Oh, I see. So this list items has, okay, so what does this list item look like? When you do map, it goes through all of these things. Is it an array? I'm very curious. So can we console.log list items? What is list items? Okay, so list items is a list. Okay, so it is a list. So when the return statement of the map function is list, I assume. Let's ask ChatGPT. In JavaScript, when you use the map function, what does it return? Oh, okay. So the map function returns an array of all the things. Map function is a array method that creates a new array by applying. Oh, this is really good. So it's saying the map function creates a new array, right? A new list that applies the function to each element of the original array and returns a new array containing the results of applying that function. That's great. So this is saying the original array, you map it, and then you give it the element and index. And then what is this? The original array, I'm guessing. I don't get this example. Index array. Okay. Oh, see, there's a breakdown. The original array is what we're calling map on. The provided function is executed for each element of the array, and the transformed element is returned. The return values are collected and used to create a new array called new array. All right, so that's what this is. The map function preserves the original length of the array. Makes sense. And here are the parameters. Element, current element processed. All right. Index. Oh, so these are optional. The index of the element processed. And array, the array on which map was called. Oh, that's pretty cool. So you can actually access the original array that the map function was called with, right? So inside this logic, this transformation logic, you can call certain features, or you can use the array that you originally called it from. That's really helpful because sometimes you don't want to just use the element, you want to use everything in the array that was called, right? So that's pretty cool. So in here, since these two are optional, this map function only has the number, right? Only has the element. With just the element, you can do something to the element, so it basically doubles the number, and then it outputs and it generates the output. And it's kind of crazy how ChatGPT can generate these programs. That's pretty cool. So it says in the above code, the map function is used to double each element in the numbers. Makes sense. Okay, so this is super useful. In fact, ChatGPT actually saves a lot of time. Imagine if you went to the documentation for JavaScript and had to look this up. I'm sure you can. let's do the same. Actually, let's try it. So JavaScript map. Okay, so it's the MDM directory. So map object holds key value pairs. Okay, this is the wrong map. This is the whatchamacallit, the data structure map instead of the array function map. And I think Google has its own generative AI feature. Actually, I've turned on the beta, but this is Google's explanation of JavaScript map. The map method in JavaScript applies a function to each element of the array and returns a new array with the results. Here is the example. And yeah, so ChatGPT is clearly a little more detailed, even though I didn't ask it as much information. I literally typed in JavaScript map. Okay, so where JavaScript function. Okay, so a map function creates a new array populated with the results of calling a provided function on every element in the calling array. Great. So we got the same information from Mozilla, and there's different elements. This kind of looks like where ChatGPT got its information from, to be honest, except for the callback part. Okay, so there's a longer description. We can read through this if we really want to dive into maps. Let's continue. Okay, so what this made. Okay, so when we're programming, I think one really important thing to know and understand is what each line and what each section really returns, right? Like how things connect together, because that part really helps you develop your critical thinking skills, and it helps you not get stuck. When you get stuck in programming, a lot of times you run into bugs and you won't know why the bugs are there. You just know that, hey, there's a bug. Why is there this bug? The fix to this is actually knowing what you're actually doing, and even though you're stuck on a bug, you can go through and dive deeper into each individual section and check that you're doing everything correctly, right? If you don't have that knowledge, then you'll be kind of confused, and then you won't understand why you need to put something somewhere. If you understand it, then you can easily go back and say, hey, is this correct? Not, hey, what's going on, right? So what we're trying to understand here is what this is generating. So products.map, this generates an array. So all of this is just an array, right, of elements. And what are the elements? The elements are individual list items, right? So inside our array, this is what we see. And that's pretty cool. So this is probably the object representation of a list JSX, right? This whole thing is an object. So it's basically going through this list and working on every single item on the list and then sticking in a new list. So it's performing a transformation, right? It transforms the list into this final list, and then it displays the list, which is pretty cool. See, the list element includes the key and the style. And then it looks like JSX understands a list of lists, a list of components, which is pretty awesome. Okay, moving on. Responding to events. You can respond to events by declaring event handler functions inside your components. Function, my button. Okay, I just read that without thinking. So you can respond to events by declaring event handler functions inside your components. Okay, so we can declare event handlers. That's awesome. What event happened? So if you handle a click, you can alert you clicked. Oh, that's cool. And you can assign the handler to an action. So when you click a button, it goes to this function. That's pretty cool. So let's kind of understand what we're looking at. So this is a function with a button. So this thing is a component. This whole thing is a component. When you have a function inside the component, this is no longer a component. This is just a handler, event handler. When you return the button, you return one JSX element, which is the button, and it has an on-click handler that calls the inside handler. So now, if we pass the button to the rest of the program, it can handle the click. That's pretty cool. So this is all wrapped up into its own component. I think the powerful part about this is that because it's wrapped up in a component, you actually can have multiple components with a lot of different behaviors, and it'll still kind of make sense, right? It won't get clobbered, and one component won't affect another component. Updating the screen. Often you want your computer to remember some information and display it. For example, maybe you want to count the number of times a button's clicked. To do this, add state to your component. Okay, so this part I think is more complicated. What are states? So import useState from React. All right, so let's take a look at what useState is. So what states of a system is, I'm assuming from other engineering things, but states of a system is usually a kind of the state of the system. I don't know how to describe it without using the word state. It's sort of like a certain setting of the system at a particular time, right? So say you have 5 different variables. Those variables can range from 0 to 10, right? Whenever you have individual, the current state of the system is what each variable is assigned to at that time of the system, right? So say variable 1 is 1, variable 2 is 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So it's in sequential order. That's the state of the system. All variables are in sequential order, right? If you change up the order and you take a snapshot, that's another state of the system. So this state handling, or for example, this water, okay, let's use a physical example. So this water bottle, right? This water bottle, the current state is the lid is closed. There's another state of the system where the lid is open, right? So that is 2 states of the system, right? But you can also add another variable where the lid is open, right? So you can open up the lid. So this is another state of the system. The lid is open. And then you can have all these variables together. So the lid is closed and the lid is closed and the cap is closed. Or you can have the lid open, cap open, lid open, cap closed, right? So different states of the system. So it looks like React has its own state handling system, which is great. I can see this being useful because different components can have different states to them. Let's say a component is hidden right now. That's a certain state, right? A component has some person entered some information into the component, and that all of that has states to it. Okay, so this is the official documentation. It's a little dense to read, so let's just continue through the tutorial. So we import useState from React. Now we can declare a state variable inside your component. Okay, so the state variable is count and set count, and it uses state 0. All right, so what does this mean? You'll get 2 things from useState, the current state and the function that lets you update it, set count. You can give them any names, but the convention is to write something and set something. The first time the button is displayed, count will be 0 because you pass 0 to useState. Okay, that's pretty cool. useState, I see. So we imported useState. So we pass 0 to useState. That's the initial state, the initial conditions. When you want to change the state, call setCount and pass a new value to it. Clicking this button will increment the counter. Wow, this is so convenient. This is like super convenient. So what this is saying is you have a bunch of things you want to keep track of, right? You want to know how many times somebody clicked the button. You want to know how many times somebody, I don't know, typed something. You normally have to keep track of that with some data structure. What this is telling you is that React has its own state management system where you can easily define the state. The state is a count, right? A count is a state. How many times somebody clicks something is a state. And I literally just press. Okay. How many times somebody counted something is a state. In order to keep track of that, all you need to do is use this useState, right? And make this array. So make an array with 2 elements, the name of the state and the setter of the state, and then literally give the initial condition and you're done. Now it says set count because it automatically created this, right? So set count, you can set the new count now, right? And you can pull from the old count, which is count, and you can add 1 to it, and it will update the state. React will call your component function again. This time count will be 1, then it will be 2, and so on. If you render the same component multiple times, each will get its own state. Click each button separately. Okay, so that's kind of cool. So each component has its own states. When you have multiple components, the states are not shared. They're not a global state. They're a specific, they're scoped states, right? These states are only within the scope of that component. So looks like we can click the top button multiple times. The bottom button doesn't change. And then you can start clicking the bottom button will change by itself, right? And it says, and this is how we're using the state. So this doesn't have a getter function because you can literally just use the name of the getter, right? So let's do our own twist on this before we continue. Let's try to make our own button. Let's call it my mega counter button. Okay, so in our mega counter button, we're gonna count up a ridiculously large, maybe not ridiculously, but a pretty large value, a random value. So we're just gonna do math.rand again because I like random. And then we're gonna multiply it by, I don't know, 10,000. Cool. And then we don't want our button to not update at all because that'd be sad. So let's say you get at least 10 each time you update. And then let's floor this guy so that you don't have fractional updates. All right, cool. So what did we do? We made a mega counter button. We copied everything. And then we have our own count, right? This count is the same as this button. It has the same name, but because they're different components, they don't share the same, they don't share the same scope, so you can have the same name. Let's start our button off with 100 this time. We don't want 10. We want 18. We already get some free money. 18 clicks. And then this says mega counter has counted blah times. Okay, and so how do we use this? We can go to my button and just change this to my mega button. And it's not happy because I named it my mega counter button. All right, so if you look at our mega counter button, it starts off with 18 times because we instantiated the state with 18. And if you click it, bam, math.rand is not a function. Maybe it's math.random. I don't remember. Let's try it again. Bam! Wow, look at one click gave us 9,000 something, right? So this is a pretty cool large counter, right? So this is the lazy man's button. You can see the original one still works because they're different components. And then if we create 2 mega buttons, the states will be different. So now there's 2 buttons. You see the numbers are quite different because they're keeping track of their states separately. All right, that's a really cool feature. Next, using hooks. What is a hook? Functions starting with use are called hooks. Okay, useState is a built-in hook provided by React. You can find other built-in hooks in the API reference. You can also write your own hooks by combining existing ones. Hooks are more restrictive than other functions. You can only call hooks at the top of your components or other hooks. If you want to use useState in a condition or a loop, extract a new component and put it there. Okay, so I do not understand what they're saying. All right, so functions that start with use are called hooks. Let's see what other hooks there are. State hooks. Okay, so useState. Context hooks. Context lets you receive components. Okay, so all these things we have not learned yet. Let's just go back and ignore them because we did not get there yet. You can find other hooks. You can also write your hooks by you can also write your own hooks by combining existing ones. Hooks are more restrictive than other functions. You can only use hooks at the top of your components. Okay, at the top of our component. I see. So at the top meaning you can only use hooks up here, I'm assuming. Can't use it down here. And if you want to use useState in a loop, extract a new component and put it there. Okay, so I guess each component, you have to make a component per useState. We'll get back to hooks, I think. It seems like hooks is a really big topic that they just will gloss over for now. And so let's put down in our notes sheet. And let's see if ChatGPT does a better job. Okay, so in React, let's put a little sticky note, say, find out, get a deeper understanding of hooks in the future. And then we'll ask ChatGPT, dear ChatGPT, we are working through the React tutorial and we have encountered the hooks section. This is what the section says. Where's hooks? Right here. It is a bit brief and we don't understand what it means by we can only call hooks at the top of our component. We understand what a component is, and we also period. We also don't understand what it means by when we say means when it says we can use state only means when we need to use state in a new component when we loop it. All right, so what I did for ChatGPT is I tried to describe where we are in the tutorial, right? We're saying this is what ChatGPT says, and then let me put some lines here to separate ChatGPT says. And then we say, hey, we don't what we don't understand, right? So let's click go and see what ChatGPT says. Cool. So ChatGPT is going to provide a more detailed explanation. What is hooks? Hooks in React. Hooks are special functions introduced in React that allow you to use state and other React functions within functional components instead of having to use class components. Okay. They enable you to manage state, perform side effects, and access other React features without the need for a class. The rule of hooks. The rule mentioned in the tutorial states that the hook should only be called at the top level of functional components or other custom hooks. What this means is that you should not call hooks inside loops, conditions, or nested functions within your component. Okay, so you can only use it outside of loops, conditions, and nested functions. In other words, hooks should be called in the same order on every render of a component. They should not be called conditionally or within any nested blocks. This rule ensures React can keep track of the state and other internal data associated with hooks correctly. Okay. For example, consider the useState hook, which allows you to add state to functional components. You should use it at the top level. All right, so we can only use it at the top level. This is the same example that we had in the tutorial. By adhering to this rule, React ensures the state is correctly associated. Okay. Extracting components. The tutorial also mentions that if you need to use a hook like useState within a condition or a loop, you should extract that portion of code into a separate component and use the hook there. This helps in the following rule of hooks. For example, if you want to use useState in the loop, you can create a separate component that handles the loop logic and uses the hook within it. Okay, so what does it mean by that? And so we're looking at a component, and it's going to create a list of items, right? And this component is called loop component. So it has a list of components with loop components, and each one has a state. Okay, so each loop component has its own state. I see. So for an unspecified number of components, you need to make a component for each component. By extracting looping logic in separate components, you can safely use useState within it without violating the rule of hooks. Remember, this rule ensures React can properly manage state and lifecycle of hooks, leading to more predictable and error-free behavior. Wow, this is a great explanation. Wow. This is an excellent explanation. I have a follow-up question. All right, so also, if you guys don't know how to like add returns in ChatGPT, it's the same as most other like text boxes. You just press shift and enter, right? On your keyboard, you just hold shift and enter, and then it'll just add new lines without submitting the query. If you just hit enter, it's just gonna return the query. All right, so we have a follow-up question. Also, I spelled explanation wrong. The follow-up question is, does it take memory when we create a new component for every state we keep track of in React? Is it good practice to nest components like this? And how many components can we nest? Let's say there are 1,000 items in the list. Would we need to make 1,000 components? What if they are also nested? That would scale exponentially. All right, so my question is, if we create a new state for if we need a new component for every state, then we're gonna have a ton of components, right? Let's see what ChatGPT says. When it comes to using components in React, it's natural to wonder about memory usage and performance, especially dealing with large number of items or nested components. In React, creating a new component for each piece of state you want to manage does have memory costs. Each component has its own state, props, internal logic, which requires memory allocation. However, React is optimized to handle component creation efficiently, and the memory overhead of individual components is typically not a major concern. Regarding nesting components, React is designed to handle component composition, allowing you to create modular and reusable code. So nesting components is a common practice. It helps to maintain the separation of concerns and promotes reusability. Cool. In the scenario where you have a large number of items, such as 1,000 items in a list, you generally don't need to create a separate component for each item. Instead, you can leverage techniques like list rendering or pagination to handle the rendering and management of items efficiently. Okay, so it's saying that it's kind of ridiculous we have 1,000 items in a list. For example, it's going to say we can use the map function to iterate over things. This way you can create a single component. Okay, I mean, that's fair. In above example, we are rendering a list of items using the map feature, blah, blah. React is built to handle large-scale applications. It utilizes efficient reconciliation algorithms to optimize rendering performance. It's not necessary to worry about the number of components as long as you structure your code efficiently and follow best practices. All right, cool. If you find your application requires handling of exceptionally large number of components, you can explore technologies like virtualization or pagination. Okay, so it has a memory cost, but it's optimized to handle it. All right, so I guess we don't have to worry about that because one, apparently we can have ways around it, and two, it's meant to be nested. Okay, cool. So yeah, ChatGPT actually helped out a lot from knowing almost nothing about hooks. We can actually understand hooks a lot better now, which is pretty cool. Actually, we have one more thing to ask React or ChatGPT. So besides use state for hooks, what other common hooks are there and what do they do? Okay, so there's use effect, perform side effects on functional components. The use effect hook runs after a component renders and can handle cleanup operations. Okay. Side effects may include fetching data, subscribing to events. All right. Use context. Use reference. All right. All this stuff, I think we haven't gotten there yet. So, it points us to the documentation. All right. Thank you. Don't fully understand the other hooks yet, but we will see as we get further in the tutorial. The use state hook makes sense for now. Takes time to grasp. This is very encouraging. All right, ChatGPT is quite encouraging. All right, moving on. Sharing data between components. We're almost done. Almost done. Hang in there, guys. Last one. Sharing data between components. In the previous example, each my button has its own independent count. When each button was clicked, only the count for each button was changed, right? That makes sense. However, often you need components that share data and always update together. Okay. To make both my button components display the same count and update together, you need to move the state from individual buttons upwards to the closest component containing all of them. All right, so we just need to move the state upwards. That makes sense. So you can see the state is handled in my app instead of each button. Okay, so now when you click either button, the count in my app will change, which will change both of the counts. Here's how you can express this in the code. First, move the state up from my button into my app. All right, so the state, we moved it up from my button. Okay, so we moved the code from here to my app. Let's see, so let's take a look at this example. We had the state from here. Let's move it up to my app. All right, great. Moved it up to my app, but now what do? We also need to move handle click handle count, handle click up. Okay. All right, so we want to move both of these up one component. Okay, so we'll move it to my app. Okay, I think this thing is a little bit wonky right now. Okay, I don't know why this, I'm just gonna refresh the page. The JavaScript is, all right, a little better. So we're gonna move this stuff up here to my app. Okay, and then what? So clearly the apps don't have access to count or handle click because it was in the component before. So how do we pass it down? Move it up, pass the state down from my app to each my button together with a shared click handler. You can pass information to my button using JSX curly braces like you did with built-in tags like img. Okay, so how do we pass it down? Oh, I see. So you can pass the state down to, I see. So you can pass information to the button using these tags or using some attributes on the button. I see. So how does that work? So these are called props. The information passed down like this is called props. Now the my app component contains the count state and the click handler, the handle click event handler, Now the my app component contains the count state and the handle click event handler and passes both of them down as props to each of the buttons. Okay. So on click and count and on click. Oh, I see. And then the prop can pass things further down. When you click the button, the on click handler fires. Each button's on click prop was set to handle click inside the my app function inside my hand. Okay, sorry, I can't read right now for some reason. Each button's on click prop was set to the handle click function inside my app, so the code inside of it runs. That code calls set count, incrementing the count. This is called lifting state up. By moving state up, you've shared it between components. Okay, so that's pretty cool. This is pretty cool. So I guess this is lifting a state or lifting up a state. So let's try it over here. So we have the old one. We modified it a little bit, right? So now we're gonna make a prop. So this prop is gonna be curly brackets. I know. Inside here we have count and we have set count, right? Or we have set on click because that's the handler we want. Okay, so on click is, okay, so how do we write this? Okay, so we need curly brackets to grab the props. So this would be curly brackets. Okay, so what does it say when we do this? It's not iterable. Okay, so it's not a list. It's a curly bracket. So it's a tuple or something, a double. Okay. Handle click isn't there, but we can say on click. Okay. And then the button was not passed. We didn't pass down the click or the count or the click. So we do count equals count. And on click equals handle click. And same for the second button. Great. So I think we duplicated the example. That's cool. So I do have a couple questions. So one question is what data structure is holding this together? Like, is this syntax? Okay, let's see if ChatGPT can tell us. So when you have props, you define the prop in a component. What data structure holds the props in the curly brackets? Is it just syntax? An example is when defining props, a component using the syntax blah is called object destructuring. The curly brackets is used to destructure an object and extract specific properties from it. In this case, the myButton component receives props. It expects an object as the argument. By using object destructuring, the component is extracting count and onClick. Okay, that makes sense. In the above example, myButton component expects props with the properties count and onClick. When the component is used, you can pass an object with those properties. Okay, by destructuring prop objects within the function parameters, you can directly use extracted count and onClick variables in the component without explicitly accessing them through the props object. It's worth noting that this syntax is specific to JavaScript and React, and it helps simplify the code and make it more readable by directly referencing the required properties. It's not just syntax, it's a feature of JavaScript that allows you to destructure objects and access their properties directly. Okay, so it's a feature of JavaScript. If you're familiar with ES6 objects destructuring syntax, the syntax should feel familiar. If not, it's a good opportunity to explore and learn more about destructuring objects. Wow, this is great info. It actually is really cool info. And it's really cool it understood what we're talking about. Can you give us an example in pure JavaScript instead of React so we can see this destructure? It's called, what is it called? Object destructuring more clearly. Oh, I see. This is really, oh my god, ChatGPT is so useful, guys. This is so tailored to what our question is. It literally tells us a person's here, you destructure the person. So this is the same as Python's destructuring, right? This is the same as, this is great. And it even uses it as a function, so you can object destructure functions. Oh, I see. So destructuring can be used in functions and it can be used outside of functions. Oh. That's really cool. Awesome. So object destructuring looks different in functions than in function declarations than in line code. Ah, I see. Wow. You guys, ChatGPT is such a good learning tool. It's such a good learning tool if you know what to ask it and how to ask it. This is insane. I'm pretty sure if you use ChatGPT, you just spit it some code, like you just give it some code and try to get it to debug. It probably works okay. I know a lot of people have crazy stories about that. But if you're just trying to learn things from first principles, this is like this is mind-blowing, right? This literally answers your question without having to go on Google and searching for hours. And it's so specific to your question. Okay, so it says, all right, so I think essentially this answers the question. Thank you so much. Is invaluable help. And it remembers that we're doing a web development journey. All right. Let's see. What are we gonna do next? I've lost track of what we're talking about. Oh, okay. So we understand. Okay, so we understand this a little better. That's right. We were updating our app. Okay, so this is object destructuring, which is basically taking count and onClick and destructuring it. The other question I had is why aren't we passing the handler, the function itself? Instead, we're passing the onClick. So let's ask ChatGPT again. And we'll see if ChatGPT knows what onClick meant, because this is a standard tutorial. I have another question about props. In this function, in the tutorial, we pass a prop called onClick instead of the set count function to the component. Is there a reason we passed onClick instead of set count? Could that be done instead? In the example you mentioned where a prop is called onClick is passed instead of set count, it's common practice to provide a more generic and reusable interface to handle events in the component. Let's take a closer look at the example you provided. So button onClick button. Okay, so I remember the example. OnClick prop is passed to the button element. By passing the function like onClick instead of set count, you create more flexible, reusable components. This way, the myButton component can be used in various scenarios without being tightly coupled to specific state management functions. All right. By using the onClick prop, the parent component uses myButton, can decide what action should be taken when the button is clicked. It allows for greater customizing and flexibility. Here's example usage of myButton component. So this is the handler, and it sets the count. Okay, so in this example, parent component has its own state managed by useState hook. It passes both count state and the handle button click functions as props to the myButton. Okay, so this is what we were asking. Can we pass handle button click down? myButton can be reused in different parent components without any modifications. I see. Okay, so I think this is a little more clear. This basically allows, yeah, it gives more control to the component if you pass things down. I'm getting a little tired, to be honest with you guys. It's a little bit hard to read clearly. Okay, so we are on the last section. Let's try one last thing. Instead of passing down onClick, I really do want to try passing down handle click. So handle click sets the count, right? So let's do handle click here. Handle click. All right. And then when we pass down handle click, now okay, so we essentially just changed the name of okay, so that was just a name change. Oh, we can use set count, that's right. Let's pass down set count. And the onClick we'll call set count. Okay, so I guess it's the same. Oh, objects are not valid as React child. Interesting. OnClick. Oh, I see. You need to call the event handler. So the handler, I see this. So the handler would have been here. Okay, I bet. I tried to pass. Okay, so this is what I meant about debugging. This is why you sort of should try to understand what's happening, because when you run into an error, you can actually understand what the error message is talking about instead of trying to randomly guess, right? So what the error is saying is, hey, we tried to display an object, or we tried to use an object as an event handler, right? Because set count is a function, is a setter, right? And the setter returns probably like an object or something like that. It doesn't return anything. So it's trying to set the onClick event handler to some object thing. That doesn't work, right? So what you need to do, oh, actually, no, sorry. Set count is an object. It's a function. So we're trying to call the function. So actually on click, we could just put count plus 1 here. I think that would work. And it froze. Or it's not happy. Okay, so interesting. So why is that not working? Okay, I probably created a infinite loop. Okay. Let's try putting handle click here. Okay, so maybe I made an infinite loop. Try this again. Paste this in here. Okay, so what I did was I passed set count as a prop. We're using set count and we're calling handle click. So is it happy? It doesn't seem very happy. So that's not the way we do things here, apparently. All right, so I'm gonna save this example. It's getting a little bit, the stream's getting a little bit long. So third stream. So figure out why this crashes. Put some code brackets around here. And then, yeah, but essentially we basically finished this thing, right? So this code crashes on the last section. We just wanted to try to pass on or set count down because I'm just curious. But other than that, let's put the Figma page here. Okay. And the architecture. Other than that, we got it. We finished basically, right? Okay, I don't know. Maybe I don't know if our code's broken or this thing's broken. We'll try next time. But yeah, essentially we finished the first overview, and apparently, according to this webpage, we've gotten 80% of the React components already, the React concepts already on our belt, you know? That's a lot. So next time we're gonna try to go over tic-tac-toe, the tutorial. We're gonna build a tic-tac-toe game, I'm guessing. That sounds pretty fun actually. And yeah, we'll continue from there. So thank you so much for joining us on the stream today. You can feel free to check out our Discord channel. Please come to the Discord channel to join our conversation, give input. You can feel free to learn with us. It's basically a free tutorial session, so why wouldn't you join, right? You should definitely come and check it out. It'll be a lot of fun. I'll get to chat with you one-on-one. You can give suggestions on what we want to do on the application. And yeah, it's just we want to build up a community for Y Academy and for myself as well. So yeah, just feel free to join on our chat. I'll put the Discord invite on the Twitch chat. And yeah, I'll love to see you guys soon tomorrow. So have a good rest of your Saturday.